Okay, geometry fans, our topic today is we're going to look at section 4.4, which is proving triangles congruent. We're going to do that using a two-column proof. Okay, so the objective is after this lesson, you should be able to prove two triangles congruent using a two-column proof. The idea of proof, it's basically like a set of directions. If you tell somebody, how to get to your house, the more specific you are, the more accurate you're going to be. You're telling somebody how to go from a starting point to some stopping point. How do they get there? Okay, for example, let's say we wanted to build something. Okay, these are the directions for building a shelf. Well, the first thing you have to know is what you have. So they tell you your hardware right here. That's all the different tools that you've got, the screws and covers and things like that. And then they go step by step and they tell you what to do, and they give you diagrams and they say, you put certain things together, you do them in a certain order. So that's step one. Step two, we get to there, and so on and so on. The better the directions are, the better your final product is going to be. So it's the same thing here when you're doing a proof. You are telling somebody how to get from one place to another place. And you have to justify it. You have to have valid reasons for saying things. Okay, so here are the strategies for a two-column proof. Step one, and this is going to sound really obvious, read and understand the given and the proved statements. Where you are starting, where you're trying to get to. If you don't know where you're trying to go, how are you going to know when you actually end up there? Okay, so understand what it is, where you start, where you need to finish. Step two is to draw and label the picture. And I say don't label it until it's written in your proof. Okay, I'll come back to that in a second. And then step three is look for relationships. If you want congruent triangles, you have to show that other things are congruent. You have to show angles are congruent. You have to show sides are congruent. So you have to look for relationships that give you that. So for example, if you have two lines cross, you always know that vertical angles have to be congruent. Okay, so we got vertical angles. That gives you congruence. So you always look for that. Vertical angles are always congruent to each other. When you have parallel lines, if I say that the top and the bottom of this four-sided figure are parallel, and then I draw a diagonal right here, now you've got, with parallel lines, look for that letter Z. Those are alternate interior angles. They're always congruent. So you want to look for that. Parallel lines will give you congruence. This is alternate interior, I'll just say INT, alternate interior angles congruent when the lines are parallel. So when we have parallel lines. Okay, so now let's see, what else gives me congruence? Okay, I'll draw the same picture here, and I'll draw the same diagonal. Now I don't need to know that they're parallel to know that both triangles have the same side. The top triangle and the bottom triangle both share this side. That is a common side. So that's always congruent to itself. That's a common side. And we call this the reflexive property. This is what we talked about a couple days ago. Reflexive property. If you have, okay, give you a different situation here. If I tell you, I'll call this A, B, C, D. If I say that AC bisects BD, AC bisects BD. Now you know that bisect means to cut in half. So if AC is bisecting BD, then that means that this segment and this segment, those are congruent. Okay, I'm going to call this point here, I'm going to call that E, that's where the two lines intersect. If AC bisects BD, then that means BD gets cut in half, and what that means is that this segment BE is congruent to this segment DE. So I would say BE, segment BE is congruent to segment DE. Something else that would give you things that are perpendicular. If we have, let's say, this picture here, if you're told that something is a midpoint, if I say D is a midpoint, then what you know is that these are congruent. Okay, so these are all the relationships. This is what we've been talking about for the last, 3 units. This is the fundamental stuff that you have to know, because now we're starting to make connections. That when you see certain things, you're allowed to conclude certain things. One other thing that we'll put here, I know we don't have a lot of space. If you know that something is perpendicular, you know you have right angles, and if two things are right angles, then they have to be congruent. So perpendicular tells you something. All these words, all these pictures give you information. All right, so let's look at some examples here. Example number 1. Well, I love proofs. Proofs are fun. By the way, I did not tell you a geometry joke yet, or a math joke, so here's your math joke for the day. What does a bull use to make computations? And the answer is a calculator. Calculator. Haha. All right, so here we go. Here's a picture. We got two triangles. Given. Given is what they tell you to start with. Segment AB is congruent to segment AD, and segment BC is congruent to segment DC. What we want to prove is that triangle BCA is congruent to triangle DCA. Okay, so the first thing you do with this, your given statement is always number 1. That's where you start. We have statements and reasons. We have 2 columns. The statement will write down what's true, the reason, why it's true. So number 1, we'll say segment AB is congruent to segment AD, and we'll also write down BC is congruent to DC. Now sometimes in some textbooks you'll see them write this as like step 1, step 2. We're going to make this all statement 1. The reason, why can we say that? Because they tell us. They give that to us. So that is given. Now once you write it down in the proof, we're going to go to the picture, we're going to label it. So AB, segment AB is congruent to segment AD. We'll put our congruent marks there. And then segment BC is congruent to segment DC. Now right now, we've got 2 sets of corresponding sides congruent. To prove congruence, you have to know 3 things. We have 2 things. So that was given. We need something else. So if you look at the picture, is there anything else that you know has to be congruent? Now, part of the problem with this is that when you look at these, angle B looks congruent to angle D, but we have no way of saying that that's true. We don't know that yet, so you can't say it. What we do have, though, is the 2 triangles meet at segment AC. So we have a common side. Now what I'm going to do is I'm going to write it down in my columns first. So statement 2 will say AC is congruent to AC. Why? That's called the reflexive property. Okay, so it's reflexive. Now I'm going to put it in my proof. The reason why I tell you to write it in the columns first is that sometimes we'll label it because we see it, but then we forget to put it in the proof. If you don't put it in here, it's not going to work. All right, so let's see. If I look in my proof, 1, 2, 3 things are congruent. So now I'm thinking, where are we trying to get to? We want to say that triangle BCA is congruent to triangle DCA. Well, now we can. Because if you look at this picture, we've got 3 sets of corresponding sides congruent. And that's what we call side, side, side. So we can say this is our last step. The proof statement is always last. The given statement is always first. Why are the triangles congruent? Side, side, side. SSS. And that's it. That's a proof right there. All right, let's look at another example. Let's look at example number 2. So this time they give us the overall figure is some kind of quadrilateral, 4 sides, given angle 2 is congruent to angle 3, and angle B is congruent to angle D. Prove that these two segments are congruent. Well, statement 1 is given. Angle 2 congruent to angle 3, angle B congruent to angle D. The reason? It's given. They give you that information, they tell us that that's true, so we assume it's true. Let's go ahead and label. So we've got angle 2 is congruent to angle 3. Now these are arcs, or these are angles, so we use arcs to show that they're congruent. And then angle B, I'm going to use 2 arcs, is congruent to angle D. Now, one thing to notice is that when you look at your proof statement, they're not asking you to say that the triangles are congruent. They're asking you to say that 2 parts, in this case sides, segment AB and segment CD, we're trying to show those are congruent. Now, you can't just look at it and say, oh, they look congruent, therefore they're congruent. That doesn't work. You cannot just eyeball it. But if we could show that the 2 triangles were congruent, then we can say that the parts have to be congruent. So even though they don't say prove the triangles are congruent, that's what we need to do. So when I look at the picture here, we've got 2 sets of things that are congruent. We need another thing that's congruent. Well, if you look at the picture, notice they have the common side right here. Okay, now actually I just labeled it. Let me put it in the proof. I should have done that first. So we'll say AC is congruent to itself. Why? Because it is reflexive. So now if you look at your picture, if I look at the top triangle, and I could do this with the bottom as well, we've got 2 sets of angles. We got 2 angles, and then we have a side. Those are the things that are congruent. Now when I look at this, notice the side is not between the angles. If it was between them, this would be A, S, A. But because it's not, what we have here is angle, angle, and then side. Angle, angle, and then side. So we're going to say that triangle, we could say DCA is congruent. Now I do have to match this up correctly. D corresponds to B. C corresponds to A, 1 arc and 1 arc. And then A corresponds to C. The reason is angle, angle, side. So now what we've said, these 2 triangles are congruent. If the triangles are congruent, then the corresponding parts have to be congruent. So now we can say segment AB is congruent to segment CD. And that's by a rule that we have. It's called corresponding parts of congruent triangles are congruent, or what we say, CPCTC. CPCTC. So, if you're trying to prove the triangles are congruent, then you're going to end it with SAS, ASA, AAS, side, 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 one of those. If you're trying to prove parts are congruent, you first have to show that the triangles are congruent, then you go CPCTC. And that's how we do it. All right, that's the end of part 1. Go ahead and flip it on the back and we'll do part